We're going to go through a 5-mark question now. So the question says, calculate the area of the shaded segments. Give your answer to 3 significant figures. So this question is made up of a number of different elements. The first part is to know what the segment is. The diagram shows us it's each of these shaded parts. So we want the total area of those 4 sections added together. Now, in order to do that, we need to break this question down. So we need to plan it out. First thing I'm going to calculate is the area of the outside circle. The second thing I'm going to calculate is the area of the square, ABCD. And then what I'm going to do is do the area of the circle minus the area of the square. Because that's going to leave me with those outside bits, those shaded segments. Okay? And then finally, I'm going to do what the question says. I'm going to round to 3 significant figures. So, part 1. Find the area of the circle. So my formula for area of a circle is pi r squared, when in this case the radius is 8. So I'm going to do pi times 8 squared, which is 64 pi. And I'm going to leave it like that right now. I'm not going to round at this point because that would make my answer less accurate. Part 2, I want the area of the square. Now, in order to work out the area of a square, I need to do base times height. In this situation, I don't have the base, neither do I have the height of the square. But what I do have is that this distance is 8. So I'm going to label on the diagram all the other distances I know, which is that one that's 8, that one that's 8, and that one that's 8. Now, when you look at this diagram, this is a right-angled triangle here. So the square is made up from 4 right-angled triangles. Now, I know 2 of the side lengths in this right-angled triangle. They're both 8. So in order to work out this, I can use Pythagoras. So I've got a squared plus b squared is equal to c squared, where a and b are the shorter sides, and c being the hypotenuse. So I've got 8 squared plus 8 squared equals c squared. Okay, so 64 plus 64 equals 128. So I know that c squared is 128, so c would be the square root of 128. So now I can label on that this distance here is root 128. And because it's a square, I know that each of the sides has that equal value. And again, I'm going to leave it like that because it's then accurate and I've not rounded. Now, I haven't actually worked out the area of the square at this point. I need to do base times height. Well, the base of the square is root 128, with the height also being root 128. So to get the area, I'm going to do root 128 times by root 128. Okay? Now, actually, what I'm doing here, if I'm timesing something by itself, I'm squaring it. So I've got a square root and a squared. They are the inverse of each other. So actually root 128 times root 128 is just 128 centimetres squared. So I've now got the area of the circle and the area of the square. So in order to work out the area of those segments, I'm going to do the area of the circle, subtract the area of the square. So step 3. So 64 pi minus 128. And I'm going to round it. So at this point, I'm going to put it into my calculator. 64 pi minus 128, which is equal to 73.0619. When, if I'm rounding that to 3 significant figures, my third significant figure is the 0. So look at the number after it. 6 means we round up. So 73.1 centimetres squared. That's the value of that, and that's my answer. Okay? Now, what I suggest is you've used that, and I'm going to set you another question. What I would do now is pause the video and work out the answer myself. Okay, what I will do is now go through the solution so that you know whether you were correct or not when you worked it out. So, again, we're going to plan that out and we're going to do the same steps. So area of the circle, area of the square. To work out the answer, I'm going to do area of circle minus the square and then round it. So I'm going to go through these a little bit quicker this time because actually we've explained them before, we've modelled them before. So we've got pi r squared, 36 pi centimetres squared. That's the area of the circle in this one. Note that it's different because the radius is different. Okay, so for 2, again, we know that this is Pythagoras because it's a right angled triangle. So I've got 6 squared plus 6 squared is equal to c squared. 36 plus 36 is equal to c squared. So c squared in this case is 72, with c being root 72. So within this square, the base and height are both root 72, which means the area is root 72 times root 72, which is 72. So I've done those first 2 parts. Part 3, area of the circle minus the area of the square, and then I'm going to round that. So 36 pi minus 72, which is 41.1 centimetres squared. And remember the centimetre squared, the units, because it asks for you to give your answer to 3 significant figures, but it's an area. Okay, now your marks in this question, 1 mark comes from a 36 pi, 1 mark comes from getting root 72 as your value for BC or DC or AD or AB, so any of those lengths as root 72. The 3rd mark comes from having the area as 72 centimetres squared. Your 4th mark is for doing the subtraction, and then your final mark is for getting the answers. So give yourself a mark out of 5 for that question.